This problem is called multiplicative persistence. So have the function take a number parameter being passed, which will always be a positive integer, and return is multiplicative persistent, which is the number of times you must multiply the digits in num until you reach a single digit. For example, if num is 39, then your program should return 3 because 27, 14, and then 4, then you stop at 4. So what it is saying is that it is going to give us a number, and we have to keep multiplying the digits of that number until it reaches a single digit. And then we will have to return the steps it took for it to reach the single digit. In this case, it took us 3 steps to reach a single digit. So here is how we are going to solve it. First, we are going to find the base case. If number is less than 10, return 0. If the given number is less than 10, then we are going to return 0. Okay, then we are going to initialize a persistent count. In the beginning, it is going to be 0, and then we will use 2 while loops. As long as our digits are multiple digits, this loop is going to continue, and as long as the number is greater than 0, this loop is going to continue. So calculate product of digits. Now here we are calculating the product of digit. The product initially is going to be 1. Now if number 1 is equal to greater than 0, yes, so the product is going to be multiplication of the number, the remainder. Now our number is 1. Our product is now 1. Now if we divide the number by 10, and whatever the remainder we get, we are going to multiply it with this. So our number is 39. 39 divided by, if we divide 39 by 10, 3, 30, and then remainder is going to be 9, right? So this 9 will come here. Now the product is 9. Now number equals math.floor number divided by 10. Now if I, let's just say, divide 39 by 10, I'm going to get 3.9. Now I'm using math.floor, so it will just give me 3. And this 3 is going to be the new number. So new number right now for the second iteration will be 3. Is 3 greater than 10? Greater than 0? Yes. So product is going to be num divided by 10, the remainder. So the product right now is 9, right? Now if I divide 3 by 10, I'm going to get a remainder of 3. So I'm going to multiply it and get 27. Now if I come to math.floor, let me erase them. Now if I calculate the math.floor, the number was 3. 3 divided by 10, so 0.03, 30. In this case, our math.floor will give us a number of 0. So 0 is not greater than 0, so we are not going to use that loop. But the number is still greater 2 digit, because in this here we are assigning the number to product. The product was 27. So the number is 27 and we have increased the persistent count by 1. So this loop is going to iterate as long as our number is greater than 2 digit. If it is when it is less than 2 digit, then this loop is going to discontinue and our persistent count will be returned. So this is how we are going to solve it. Now let's write a base case. If number is less than 10, then we are going to return 0. Let persistence is going to be 0, while num is going to be or equal to 0. We are going to use a loop. Let product 1, while num is greater than 0, product will be multiplied with the remainder of that num, and num is going to be mat.floor num by 10. Now, after that loop ends, I'm going to assign the number to that product. Persistent count will increase by 1. And after that loop ends, I'm going to return the persistence.